Hey there, welcome back to yet another episode of SAFT podcast. It's so good to have you back with us, and it's so good to have you, Jacob, connecting back. And how you're doing? I hope you're doing good over there.
Yeah, man, doing well. Right now, as I'm recording this, there's a heavy downpour hitting Bangalore. So let's hope that it doesn't get too much picked up in the recording. But that's what's happening in the city right now. And how's the weather back there in Calcutta, Piyush?
Yeah, it's pretty good. It's been rainy at times, but then overall, it's pretty pleasant. Okay, so I think without any further ado, we should straight off dive into this episode. Before that, I'll give a quick recap of what we covered in the previous episode. We've been talking about the premise 2, which states that the universe began to exist. We spoke about the philosophical argument and about infinite regression and how it cannot be true, right? Infinite regression, it cannot be true about the universe. So that's how we spoke about that argument, and we even ended with the book borrowing and lending example, which made things very clear for us. Now, looking into today's episode, so Jacob, what do we have in store?
Yeah, so as we mentioned, we're looking at arguments for the beginning of the universe. We looked at a combination of two philosophical arguments. Now we're going to look at two scientific arguments that I think may be much along the line for most of our audience to follow along, because we're just going to quote scientific data and it's much easier to follow along than working through the philosophical argumentation part. And we're going to look at two scientific arguments for the beginning of the universe. But please, to start off with, in simple words, what is happening to the universe as we speak? Like, what is happening to the universe right now?
Talking in scientific terms, the universe is expanding because we all know about the Big Bang theory, right? Which states that the universe began from a point and it is continuously expanding. And we even know there's this amazing, funny series called The Big Bang Theory. I'm sure that most of our audience must have heard of it, and you must have come across one or the other episode. So that's what is happening in the universe right now.
Exactly. And so the first argument for the beginning of the universe is the expansion of the universe. So what happened was, in 1916, Einstein presented the general theory of relativity, and the field equations of the general theory of relativity predicted an expanding universe. Then around in mid-1920s, Alexander Friedman and George Lemaitre, they were using Einstein's work to present solutions to his equations, and that ended up predicting an expanding universe. And so what turned out was, this was one of the first many steps towards discovering and proving that the universe was indeed expanding. And then in 1929, astronomer Edwin Hubble, using the Hubble telescope, and as such, he observed the shift in the light of distant galaxies from us. And he showed what was later going to be termed as one of the most important and the first of many empirical evidence that proved the way that the universe was indeed expanding. So this was a starting point, right? When we realized, wow, the universe is indeed expanding.
Okay, but how radical was this discovery, and what was the state of understanding about the universe at that point of time? It was like a lot of years back, but what was the state of understanding about the universe at that point of time?
Yeah, so the prevalent understanding of the universe at that time was that the universe was a static universe. So people held that the universe is infinitely old, and for an infinite amount of time, the universe is static. So it isn't expanding, it isn't contracting, it is the way it is. And so what the previously mentioned Friedman-Lemaitre model showed is that it actually gave way and said that no, the universe is actually expanding. And the significance of this model comes to fore. Like, what is the significance of this model, these discoveries, against the context of the scientific understanding at that time? When you look at this quote by physicist John Wheeler, when he says, "Of all the great predictions that science has ever made over the centuries, was there ever one greater than this, to predict and predict correctly and predict against all expectation a phenomenon so fantastic as the expansion of the universe?" So this was how radical and shaken up the discovery of the expansion of the universe was against that context of scientific understanding of the universe at that time.
Mm-hmm. Yeah, and then we even like, I'm not sure if most of you know or not, but Einstein actually did a fudge in the beginning in the initial equations by adding the cosmological constant so that the effect of gravity was cancelled everywhere in the universe.
Yeah.
Now, this was to save the static model, but then later he disproved it and he called it the greatest blunder of his career. And this was in one of his, it's written in a book which is named 40 Minutes with Einstein. It was written by Wibert Douglas. So that's where we find this, like Einstein himself mentioned that this was one of the greatest blunder in his career.
Yeah, and what we see is also that the general relativity theory was not based on, and this is quite radical thing, it was not describing just the expansion of matter within the universe into empty pre-existing space, right? It's not just that matter was expanding and filling up space, but the idea that the general theory of relativity was putting forward was that space itself was expanding. And so you can see why this theory, this Big Bang theory, or others came known as a standard model, right? What we understand as a Big Bang theory was initially referred to as the standard model. And we see why the standard model was stirring up a lot of commotion at that time. The Big Bang theory was stirring up a lot of commotion because of how radical it was. So it was not any wonder that one of the most celebrated British astronomers of the time, Sir Fred Hoyle, he mocked the theory and he called it Big Bang theory. So the name Big Bang came about because it was looked down by other astronomers and scientists of that time. So what then came about was a string of different theories and models were put forward to counter the standard model or the Big Bang theory. And with Fred Hoyle himself putting forward the steady state model, where he acknowledged that the universe was expanding, but then he went about to say that new matter is drawn into the gaps as there is a recession of the galaxy. So as the galaxies are receding, as they are going away, there is a gap that is being formed and new matter is pulled into these gaps. And so this was the start of many other theories that came about to counter the steady state or the Big Bang theory model, which simply said that the universe had a beginning.
Okay. So you mentioned that there were a number of theories, right?
Right.
So can you just quickly breeze over these theories and why is the Big Bang theory still the champion among all of these?
Right. So there are a lot of theories that have been put forth, and what I'm going to do is, like you said, Peter, I'm just going to breeze through the most relevant of these, referring to their immediate objections and why they couldn't hold up. So the first one was the steady state model that Fred Hoyle brought up around the 1940s, I think 1948 or something around that time, as a strong contender to the Big Bang theory. So key point, the thing is that before the Big Bang theory was put forward, before we realized the universe was expanding, the prevalent understanding was the universe was static, right? It is the way it is expanding, not contracting. And when evidence came about the expansion of the universe, the steady state model, for example, wanted to take into account the expansion part, but still somehow argue that the universe was in a steady state. It lacked any empirical evidence. And then the Big Bang theory received a ground-shaking approval of its validity when we discovered the cosmic microwave background radiation, which many people tout as the discovery of the 20th century. And what that basically means is this. The Big Bang theory was predicting this singularity point beginning of the universe. And it had predictions about the temperature of what would have been from the leftover beginning point of the universe. So there is background cosmic radiation left over, and it had predictions about it. So when we discovered these cosmic microwave background radiation, it was proving and adding more validity to what the Big Bang theory was presenting. Because this is theory that's making predictions of what you would find in space, about the universe, and this discovery was proving it. And it was a direct outflow of George Gamow, his predictions based off the Big Bang theory that this discovery substantiated. So steady state model took a big hit and it receded out of scientific inquiry. Then came the oscillating model. And what it said was there is this constant phase of contraction and expansion of the universe. So the universe is contracting and expanding and contracting and expanding, and this is going all the way back into past infinity. But then the Hawkins-Penrose singularity theorem Stephen Hawking's. And so the Hawkins-Penrose singularity theorem, named after themselves, disproved and shut down the oscillating model that was put forward there, which then led to Hawkins to say the famous quote. Instead, almost everyone now believes that the universe and time itself had a beginning at the Big Bang. So the oscillating model took a hit. Then came the chaotic inflationary model. So this was similar to another model called the vacuum fluctuation model. And we don't have time to go into all of those, but I'm just picking out some unique ones because of the distinctions between each other. So this chaotic inflationary model just showed that there are numerous domains, simply put, universes, right? Numerous domains of inflation, and these continue to expand further. And the reason that they expand is because of a beginningless and endless series of inflation, right? So there is a series of inflation that is happening, and these independent domains of universe are also expanding and inflating as a result of this beginningless and endless series of inflation. So you see how these theories are in one way or the other trying to account for the expansion that they're observing in the universe. They've moved away completely from the static view of the universe, then trying to account for the expansion of the universe, but then somehow avoid a beginning for the universe. And then Arvind Bode and Alexander Vilenkin, two very famous cosmologists, they showed theoretically that all of these models fail. So they go on to say that, can this model also be extended to the infinite past, avoiding in this way the problem of initial singularity? This is in fact not possible in future eternal inflationary spacetimes, as long as they obey some reasonable physical conditions. Such models must necessarily possess initial singularities. In fact, the proponent of this chaotic inflationary model himself accepted the conclusion that Bode and Vilenkin put forward. And then came the quantum gravity models. And the interesting point of the quantum gravity models is that the whole model is able to do away with the initial singularity by introducing imaginary numbers. Now, we don't even know how these imaginary numbers even relate to the real world. So this was a big flaw of the quantum gravity models, that they were using imaginary numbers to do away with the initial singularity, the initial beginning point and as such of the singularity that we find with the steady state model, that sort of a singularity. And Hawkins clearly says that only if we could picture the universe in terms of imaginary time would there be no singularity. When one goes back to the real time in which we live, however, there will still appear to be singularities. So the way to do away with the initial singularity that the Big Bang theory, or otherwise known as the steady state model, was putting forward was to introduce imaginary numbers, imaginary time, that even Hawkins admits doesn't even exist in the real world. And he says if you come into the real world and use real numbers and mathematical concepts that we are using in the practical real world, then you will end up with the initial singularity that you find with other theories. So quantum gravity model has that massive flowback. Then comes the string scenarios. And the most celebrated, and string theory is still a very speculative, widely celebrated field, even in the Big Bang theory TV show. M theory, string theory is often quoted a lot and put forward as the next big content, or the next big thing in cosmology to give us answers to a lot of stuff. And the most celebrated and one of the most revised versions of the string theory, called the cyclic ekpyrotic scenario. Thankfully I pronounced it right. So the cyclic ekpyrotic scenario was put forward to explain as one of the better explanations of the string scenario. But then what happened was, remember I initially mentioned Arvind Bode and Alexander Vilenkin and how their work showed that the chaotic inflationary models and other inflationary models cannot work out. In 2003, they teamed up with Guth, and they presented the Bode-Guth-Vilenkin theorem. And what it showed is that it restricted out any sort of ruling out of boundary in the past for an expanding universe. Basically, they say that if the universe is expanding, right, if there is expansion happening in the universe, then it must have a boundary in the past. It cannot be eternal in the past. There must be a starting point. There must be a singularity. It cannot keep on expanding all the way into past eternity. And this was what the Bode-Vilenkin theorem initially showed in 1994, around that time, that led to the disproving of chaotic inflationary models and similarly vacuum fluctuation models and as such. But then, like I said, in 2003, the model was even more substantiated when the updated Bode-Guth-Vilenkin theorem came out, which said that, simply put, any universe that is expanding into the future must have a past boundary restricting the expansion into the past. So you're moving again to the point of a singularity, moving closer to the Big Bang theory and the standard model. And this was sort of like the death bell for any theory trying to fit in an eternally expanding universe into the past. So this is sort of the state of affairs of how different theories have been put forward to try and compete and push out the standard model, or otherwise known as the Big Bang theory.
Okay, so these were the theories, right? Now, since you spoke about Vilenkin, there's this quote which he I'll just quote him. He said that an argument is what convinces reasonable men, and a proof is what it takes to convince even an unreasonable man. With the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. This is what Vilenkin said in his book, Many Worlds in One. So Jacob, this was the first argument of today's episode. So what is the second argument?
Okay. So the first argument was about the expansion of the universe, how the expansion of the universe and the scientific data show that the universe must have a beginning. That's what the Big Bang theory says. We looked at, again, to recap, because we covered a lot of points. There's much more to go through, but it's a very summarized version. And then again, if you think about responding to these podcasts, even right now I can think about a couple of responses questions that I can ask myself. We're giving a very summarized, very snippeted view of the entire thing because of time constraints and wanting to get you into this field of dialogue, right? So if you want to respond to the bigger sets of work out there, respond to the book Reasonable Faith, which is the syllabus book for this whole series. There isn't much point in responding to our episodes because we admit that we are giving a very simple, summarized, shortened form of the whole thing. So the first argument was that the first scientific argument is that the universe is expanding, and it points to the fact through, like we see, through a review of multiple theories and seeing how the Big Bang theory is the best validated theory of all, that the universe must have a beginning. The second scientific argument is, and let me use this example, right? So Piyush, I don't know if atheist scooters are pretty popular back there in Calcutta, the electric scooters, but they are a big thing here in Bangalore. So imagine I have an atheist scooter and it has a capacity of 100 units of charge. Now, you are a science student, so you may use joule and other terminologies and stuff, but I have no idea. So I'm just going to call it that it has 100 units of charge. And each minute of driving causes it to consume 1 unit of charge. Okay? And imagine you're driving along and you're not charging at any point, or you're not stopping anywhere. Imagine I'm just driving along this scooter, which is consuming 1 unit of charge every minute. Now, how long can I drive that scooter, Piyush?
100 minutes.
100 minutes, right? It's taking 100 units of charge every minute. And so the maximum I can drive is 100 minutes. Now, if I come to pick you up, right, and you know these details about the scooter, 100 units total, 1 unit per minute, I've been driving, didn't stop anywhere, didn't recharge anywhere. If you know all of these details, and I tell you that I've been driving for 4 hours without charging, would you believe me?
No, that's not possible.
Right. And so this example is basically what the second argument is all about. The second argument has to do with the second law of thermodynamics of the universe. And it simply said that the universe is a closed system. Now, atheists also would obviously agree that the universe is a closed system. Right? This material, natural universe, reality is all that we see. There is nothing beyond it. That's all there is. So universe is a closed system, which means that it isn't having an infusion of energy from anywhere else. All the energy that it has is all there is. So no one is charging or topping up the energy within the universe. And then the universe is slowly running out of energy. The second law of thermodynamics is pointing towards that fact, that the universe is slowly running out of energy. I think the right way, the more technical term to say is that we are moving towards a state of equilibrium. Piyush is nodding, so I think I've nailed that. Piyush being a science physics student. So the universe is slowly moving towards a state of equilibrium. In simple terms, the universe is slowly running out of energy. So if the universe has a limited amount of energy, because no one is winding it up, no one is adding energy to it, it's a closed system, whatever energy it has, and it is slowly running out of energy. How is it possible that we could have been here for an infinite amount of time with a finite amount of energy that has been slowly running out over the course of time, right? So in the analogy we said 100 units of
Yeah.
charge, 1 unit per minute, and then trying to ride for 4 hours as opposed to 100 minutes. 4 hours seem pretty close to 100 minutes, but if you see that 4 hours is more than 4 hours, it basically stands in as a substitute for eternity. If you have a limited energy that you're slowly running out of, how is it possible that you could claim to have been running for all of eternity, that for an infinite amount of time? This is the objection, which means that the universe is a closed system, it has limited energy, it is slowly running out of energy, but we are still here, which means the universe has not been doing this for an infinite amount of time. It has just been doing this for a finite amount of time. And the scientific data is pointing towards the fact that we are looking towards an eventual point where we will run out of energy. The difference between the pull of the gravitational force and the push of sort of the dark matter cosmological constant is acting together, that we will eventually reach a state of, I think it's called a heat death or something of that sort, where we will just run out of energy. The universe is done with energy. There's nothing more to sustain the universe, expansion, all of that stuff. But we are still here, and the universe has limited energy, which means that we have been here only for a finite amount of time. And Paul Davies, one of the most celebrated cosmologists of our time, not a Christian, Paul Davies says that today few cosmologists doubt that the universe, at least as we know it, did have an origin at a finite moment in the past. The alternative, that the universe has always existed in one form or another, runs into a rather basic paradox. The sun and stars cannot keep burning forever. Sooner or later, they will run out of fuel and die. As this final state has not yet been reached, it follows that the universe cannot have existed for an infinite time. So much so that Dr. Craig himself notes that this second argument is, in some sense, much more stronger than the first scientific argument, because the second law of thermodynamics is sort of like a closed science. It isn't something that is constantly adapted or evolved or put to scrutiny with so much speculations. It's a closed science. The second law of thermodynamics holds, and there's no objection. And it turns out the second law of thermodynamics shows quite strongly that this closed system universe with limited amount of energy could not have been running for an infinite amount of time, and which means that the universe must have had a beginning in the past, or in other words, the past of the universe is not eternal. We have been here only for a finite amount of time and not an infinite amount of time. And those two are the two scientific arguments for the beginning of the universe. The expansion of the universe is the first one. It shows that the universe did have a finite starting point in the recent past. Now, we've shown how the Big Bang theory holds out and how other theories have failed to hold out. We mentioned how theories like the Hawkins, Penrose singularity theorems, the Borguth-Willingen theorem all point towards it. And even right now, this field is still into so much of contention and objection, and people refer to the Planck era, which is this very extremely unimaginably small portion of time after the singularity gave away, and we are trying to fit in quantum mechanics and quantum theory to do away. But all of these theories, like for example the Borguth-Willingen theorem, still holds, no matter what we know about the Planck era or what happened before the Planck era. No matter what was the physical properties of the universe around that time, these theories hold in one way or the other. And then if this argument isn't convincing, we've looked at the second argument, the argument from the second law of thermodynamics, that the universe is running out of finite energy, but we are still here, which means the universe has not been doing this for an infinite amount of time, and that the past of the universe is not eternal. So these are the two scientific arguments for the beginning of the universe. I know we covered a lot of stuff, but I hope they were intelligible enough to listen through and figure out.
Yep. And with that being said, we have reached our 20-minute mark, and we tried our best to keep all this content within 20 minutes, and I hope that it's clear. If you have any questions or queries, you can reach out to us on our social media pages, and if you want your question to be featured on the podcast, so you can use the SpeakPipe link. It is mentioned in the description, And for latest updates, I'll encourage you to follow us on our social media pages. And you can even sign up for our monthly newsletters so that you'll stay updated with whatever is happening at SAFT on a monthly basis. And thank you all for joining in today.
It's by now,
yeah?
I'm pretty sure that our blog is already out by the time that this episode comes out to you. So yeah, so we hope you head over to blog.saftapologetics.com. It's there in the description, and you sign up and stay connected in the loop with all the articles that are going to come out on the blog. So hope that helps you as well.
Yeah, trust me, you'll find some good and exclusive content over there. So make sure to tune in and check it out. So I think that's it from today's end of the episode. Thank you guys for tuning in. We'll see you in the next one. Till then, stay safe and take care.